Okay, let's talk about transformations of functions. Um, we're going to look at, or many times you'll see functions in the form of y equals a times f of b times x minus h plus k. And part of that, that may look a little familiar, but we're going to kind of dive into that today. So, transformations. Transformations can include translations, stretching and shrinking by a scale factor, and also with reflections. And so that's what we're going to be focusing on today. You'll need your calculator, so hopefully you've got your calculator handy. I want you to graph the function f of x equals the square root of 9 minus x squared. I'll pull my calculator in. Remember that, and I'm going to scoot this up a bit. Your y equals button is right here. Go in and type in the square root of 9 minus x squared. And I would set our window, there's your window button. Let's set your x's from -6 to +6 and let your x scale be 1. And do the same thing for your y min and y max. Okay, so now that we have our window set and the equation of this function in y equals, now we can press graph, which is right here. And you should be seeing your graph being drawn. Okay, so here we have this graph. It is a function. You can see it's a function. It passes the vertical line test. But here's what I want us to look at. I want us to take this graph and I want us to graph the following functions and see what effect or how these graphs are different from this graph. Okay, so I'm going in, you do the same. I'm going to start. I'm going to keep y1, the square root of 9 minus x squared. Then I'm going to go to y2 and I'm going to type in this next function, the square root of 9 minus, now notice I've got a set of parentheses, parentheses x minus 2, close the parentheses, and then square. And then I like to get out of the radical. I'll use my down arrow key to go to y3, and I'll put in the next equation or function. Go back, get your square root, and 9 minus parentheses, x plus 3, close the parentheses, and square it. And then I'll get out of that. Now I'm going to stop there, and I want us to go ahead and graph these two before we graph these two. So I'm going to push graph, and there's the original. There's the equation in y2. There's the equation in y3. So what you've noticed, I hope, is that this has given us a horizontal translation. The graph has been shifted. The mom and daddy blue graph, the parent function that's blue, has been shifted horizontally right or left. Now, if you paid attention, you should notice that. I'm going to go back to y equals. You can just look at mine. If you do, don't worry about what I'm doing right now. I'm just trying to regraph. So watch what happens. Notice what's in y2. X minus 2 is squared. And then in y3, we have x plus 3 is squared. So I'm going to press graph. Here comes the original. And here comes what was in y2. Now remember, what was in y2 was x minus 2. And the graph of the blue graph has been translated or shifted 2 units to the right. If you look at this point, it's over 2. If you look at this point, it's over 2. And basically every point on the blue graph has been shifted horizontally 2 units to the right. Okay, I'm going to go ahead and bring in the next one. And you'll see that Y3 has been, the result is that this blue graph has been shifted 3 units to the left. 1, 2, 3. The blue end point here, 1, 2, 3, has been shifted here. This end point, 1, 2, 3, and every other point on this line, not line, but every other point on this curve has been shifted 3 units to the left. Okay, so if we take a look at these two functions, and these two graphs have given us a horizontal shift or a horizontal translation, then maybe think about what you expect to see when we graph these two. Okay, so I'm going to go back into y equals, and I'm going to keep y1, but I'm going to clear out y2 and y3. So in y2, I'm going to put the square root of 9 minus x squared. And here's where you've got to be careful. You got to be careful to get outside of the radical. So use your right arrow key and then type +2. And I will go to y3 and go get my square root, 9 minus x squared, and get outside of the radical and subtract 3. So I'm hoping that you're thinking or have thought about what you think you would see when you graph this, and now we're going to see if you were correct. So here's the original mom and daddy graph. Notice that this graph, the red, is the result of shifting the original blue graph up 2 units. And now I will continue with the next. And this last graph is the result of taking the blue graph and shifting every point on the blue graph down by 3. So a translation, I'm going to pull my calculator away. A translation is a left-right shift and an up-down shift. And what you have to remember about a left-right shift, that left-right shift is always going to come from whatever's being done to x. So if we look at this piece, notice that h is inside the parentheses with x, and I like to think of h in this form as being horizontal. That's what helps me remember how or what effect h has on the graph. It is the horizontal shift. Horizontal. And what you also have to remember is that h will shift the graph the opposite of what you think. So here, x minus 2 is going to shift the graph 2 units to the right, and this x plus 3 is going to shift the graph 3 units to the left. And then these two, notice that the +2 and the -3 are added and subtracted outside of the radical, and so that's going to represent k. And so the k gives us a vertical shift, that up or down shift, and it will shift the graph. This k value shifts the graph exactly as you think it should. So this was shifted up 2, this was shifted down 3. Okay, so let's just kind of put this in practice. Let's see what we've got here. Let's take the parent function, which we should be familiar with, y equals x squared. Remember, that's the mom and daddy graph of a parabola. Opens up. And all I want us to do is to describe the translation of this function. So x minus 3 squared is going to shift the graph 3 units to the right. and 5 is going to be shifting this graph 5 units down. Okay, so what would that look like if we were to graph this? Well, if you take the vertex of your quadratic and you shift the graph 3 units to the right and down 5, 1, 2, 3, 4, 5, then your vertex is here and it still opens up, and every point on the quadratic will be shifted down 5 units. Okay? Shifted down and right 5 units. Okay, so now let's take f of x equals the square root of x. And this particular graph is a square root function, which behaves this way. And it's write the equation of f of x with a vertical shift up of 5 and a horizontal shift left of 17. Okay, so f of x equals, okay, I know I'm going to have a square root of a vertical shift of 5 up means you're going to add 5 outside, and a horizontal shift of left of 17 is going to be x. Remember, you have to do the opposite of this, so if it needs to shift left, then you would have x plus 17. And so if you take this particular mom and daddy parent function and shift this 17 to the left, that's a lot, and up 5, your graph would be over here somewhere. And you can actually take time on your own and actually graph both of these and just look at them. You may have to change your window a little bit so that you can see this function, but this particular function has been translated 17 units left and 5 units up. Okay, so now let's talk about the scale. A scale, I'm hoping comes to mind, or what comes to mind is a shrink or a stretch. Okay, so stretch slash shrink. So going back into our calculator, oops, I gotta turn it back on. I'm going to go into y equals, and I'm going to keep y1, but I'm going to clear the rest. Well, okay, I'm going to clear the rest out, but go back to y2, and let's type in 2, and then not absolute value, but square root of 9 minus x squared, and then we'll do the 3 times the square root of square root, there it is. Well, I don't know what I did there, but 9 minus x, and I better double check that. Yes. Okay, so when I graph this, we're going to see the mom and daddy graph, and then we're going to see what effect the 2 and the 3 multiplied by that radical is going to have. So here we go. Now here's the mom and daddy graph, and I'm going to stop. So this was the 2 times the square root of 9 minus x squared. Notice that the graph stays between -3 and +3 for x, but what has changed are all of the y values. All of the y values have changed by a factor of 2. Okay, so a nice point to look at to verify that, this point right here, when x is 0, the y value is 3. Notice that if you multiply that by 2, then you get 6, which is where that point is. So this does not give us a vertical shift. It gives us a vertical stretch. Okay, so now let's go ahead. I'm going to go ahead and finish this out. And more than likely, I'm not going to see the top of this graph because the 3 has multiplied my y values by 3. And so this y value right here of 3 is now stretched up to 9, which is off the graph. I could go in and change the window, but I'm not going to go do that. So, what do you suppose 1/2 and the factor of 1/2 and factor of 1/3 will do? Let's just go in and see. So, I'm going to go in here and delete that, but I'm going to insert parentheses 1 divided by 2. And I will delete the 3 and I will insert, this just keeps me from having to retype the square root of 9 minus x squared, parentheses 1 divided by 3. So this is my 1/3, the square root of 9 minus x squared. I will graph. There's the mom and daddy graph. And we have our 1/2 the square root and now 1/3 the square root. So what have we seen? What we've seen is that for this set, the A value here, let's get here, the A value is going to be a vertical, it's going to indicate a vertical stretch. So this is a vertical stretch. And this is a vertical shrink. So it shrinks all of the y values. By a 1/2 and a 1/3. All right, so now let's look at this example here. Now this looks kind of strange the way I have them written, but I wanted to leave all of these in this form without squaring all of these, because I wanted you to see the difference between this set of problems and this set of problems. So here, the 2 on the the 2, the 3, the 1/2, and the 1/3 are factors that are on the outside. These 3, this 3, this 4, this 1/2, 1/3, these are factors that are inside, and they are multiples of x, or they're multiplying by x. So let's go in and keep y1, and I'm going to clear, I didn't clear that one, and I'm going to put the first 2 in there. So I have the square root of 9 minus, I need parentheses, 3x. I need to close the parentheses and square. I'm going to get outside of the radical, and I will go to y3, and I will put in the square root of 9 minus parentheses 4x, close the parentheses and square, and I will get out of that. So, all right, now we're going to push graph and see what the result is. So graph, now there's your mom and daddy graph right there. I stopped it. Now here comes what's in y2. So what do you see is different? What effect has the x is being multiplied by 3 here, the x being multiplied by 4, the x, oh, I didn't do those 2 yet. Think about that. What has happened here? Well, your x's, notice that your x values, this graph, the mom and daddy graph, now is no longer between -3 and 3. It has, the x values have shrunk. So how much do you think they have shrunk by? So if you take this x value right here, that is 3, and you divide by 3 or multiply by 1/3, you get 1. And so that x value moves to x equals 1, I believe, yes. So I'm going to trace trace 3, or it doesn't matter, I can use that one. And then if I want to see what happens with 1, you'll see how the blue value went to, or the point at 3 went to the point at 1. And it's because the x values are multiplied by a factor of actually 1/3, not 3. Okay, so let's, I graphed the one that's at 4 also. And so this point, the black point right there, on the black graph, since the x was multiplied by 4, then if we took the point at 3 and multiplied it by 1/4, then my x value for that point on the black graph, let me get up here on it, and I type in 0.75, you'll see that that's where that point is also. So these two have a horizontal shrink, and it shrinks horizontally by a factor of 1/3 and 1/4. So having looked at that, what do you suppose is going to happen here? Well, let's go in and see. Okay, let's see what I'm going to do here. I'm going to open another set of parentheses. This is just really no fun. Insert, divide by 2. Nope, forgot my 1. Okay, so 1 divided by 2. Close the 1/2. Type my x. Close the parentheses. And let me make sure that looks right. 9 minus that. Okay, I'm happy with that. I'm going to do this one before I do that one, just because, and I will go clean this out. All right, so I will graph, and here comes the mom and daddy graph. And notice what happens here is that this graph has had a horizontal stretch of 2. It has a horizontal stretch by a factor of 2. All of the x values are are doubled what they were. So for example, this x value of 3, if you multiply that x value of 3, you get 6. And that is true for all of these values. And so likewise, f of x equals the square root of 9 minus 1/3 x all squared is going to be a horizontal stretch of by a factor of 3. And so if I go back in, and I'm actually going to not retype this whole thing, I will change that denominator to a 3. Yeah, to a 3, and I will graph. And there's the mom and daddy graph. And I think you can tell without me going in and changing the window how this graph is being stretched even more horizontally by a factor of 3. So let me pull this away. So now let's kind of tie this all together. So let's go back to a very familiar function, f of x, or y equals, x squared. And let's describe the scale for this particular quadratic. And the scale is that there is a vertical stretch, because the vertical stretch is because 4 is being multiplied by all of this. So this is going to be a vertical stretch of 4. And let's talk about this one. Now this one's going to look a little different. Well, let's rewrite this in a little bit different form. That coefficient of 2 is kind of bothering me a little bit when I'm trying to get an idea of what this function would look like. I'm going to do this. This whole thing is still squared, and then minus 5. But I want to factor a 2. I want to factor out a 2 between those two. And we have 2 times x minus 4. And all of that is squared minus 5. Okay, so what does this kind of tell me? Well, first of all, being that x is being multiplied by 2, then we know that this will have a vertical, nope, not vertical. Since the x's are being multiplied by 2, we will have a horizontal. So think about this. Will it be a stretch by a factor of 2, or will it be a shrink by a factor of 1/2? All right, so with the horizontal stretch or shrink, remember, it's always kind of, not, I hate to say the word opposite, but it's the opposite of what you think. You would think that this would be stretched horizontally by a factor of 2, but this is actually a horizontal shrink by a factor of 1/2. Okay, and then let's talk about the other. Oh, I didn't do that up here either. All I'm asked for is the scale. Never mind. So this is all I asked of this problem right here. The horizontal shrink of 1/2. Here we had a vertical stretch of 4. So whenever the 2 or a coefficient, x has a coefficient, that's going to be the horizontal stretch or shrink. And whenever the 4 is on the outside, that will be the vertical stretch or shrink. Okay, let's do this one. Now it says, here's a parent function, f of x equals x to the third. And I want us to write the equation of f of x with a vertical shift down of 5 and a horizontal shrink by a factor of 1/3. Okay, so vertical shift, that's a k. So k will be a -5. A horizontal shrink by a factor of 1/3 means I have to have a 3x. Okay? So here we go. F of x equals parentheses 3x all squared minus 5. Okay? If I don't put the 3 inside the parentheses with the x and it's on the outside, then the graph is going to have a vertical stretch by a factor of 3. So here's your equation. And then we have, write the equation of f of x with a horizontal shift right of 2. Okay, horizontal right 2 means I'm going to have an x minus 2. Vertical shift of up 3, and I'll have a vertical stretch by a factor of 4, vertical stretch. So our equation will be f of x, vertical stretch of 4, so that's 4 times the horizontal shift of right 2. We need to cube this, and guess what I didn't do there? I just noticed I squared that. That should be cubed. All right, so 4 times x minus 2 cubed. What have I left off? And a vertical shift of up 3. Okay, so let's take a little time there to process that, and then I want to, in the next video, come back and look at reflections.